I'm Anil Kumar. Welcome to my series on trigonometric functions. We'll discuss how to write general solution for any trigonometric equation. So I'm going to discuss few fundamental concepts here. Let us consider the function cos x. Now, if I give a value to this function as, let us say, 1 over square root 2, and we want to find solution of this equation, then how do we get general solution? That is the main topic. Now, as you know, cos x is a periodic function, right? And it repeats after every 2 pi. So we can say 2n pi, where n belongs to set of integers, right? So in general, we can write like this. So the solution of this function will be repeated after every one cycle of 2 pi. Graphically, you can see that cos x graph will be, let's sketch one. Okay, so let me start from here. And so on, right? So if I'm saying that cos x is 1 over square root 2, that really means that a line at one over square root 2 will be intersecting the graph at different points. So we are looking for these values, right? We are looking for these values. Does it make sense? Let's say this is 1 over square root 2, right? So this is the cosine function, and this is x-axis. So all these points are part of our solution, right? So the answer should include all this. How do we do that? Well, one way is that we can think about the coordinate plane, and we know we are looking for positive 1 over square root 2, and knowing that all are positive in quadrant 1, sine in 2, tan in 3, and cosine in 4, we'll get solutions in quadrant 1 and in quadrant 4 for cos being positive. Does make sense, right? Now from the special triangle, let me draw one here. So these are very important tools to remember to solve any trigonometric function. If these sides are 1, 1, then the hypotenuse is square root 2. The angle here is pi by 4, right? So this is a right triangle. So what we notice is that the solution is either pi by 4 or minus pi by 4, correct? Any angle seen clockwise is negative, counterclockwise is positive. Now, this value of pi by 4 and minus pi by 4 repeats after every 2 pi. And therefore, we can write solution as x equals to 2n pi, and the values are plus and minus pi by 4. Does it make sense? Now it becomes a general solution for the given equation, right? Where n belongs to integers. Is that clear? So I hope you understand these periodic functions will have infinite number of solutions, and those could be represented in this form. So for a cosine function, it could be kind of like this. Is that clear? Now let's take up example of a sine function, right? So that's first example. Now let's example 1. Now let's take example for sine function. In sine function, what happens? Let me take some other value. Let's say sine x equals to square root 3 over 2, right? Let this be the case. Now, if you sketch this if you sketch this, how will you see the result? Let's say, let's make a sketch. Sine function starts from origin. So let's select this. Okay. Now these drawings are not to the scale, but they communicate you what we're trying to figure out. So let's say square root 3 is somewhere here. Square root 3 over 2. Now you can clearly see that there are different solutions. If you look into the coordinates, we know sine is positive in quadrant 1 and in quadrant 2. Good. So we are expecting two solutions in one cycle. Perfect. We can consider a special triangle. You can always use calculator. So in this special triangle, the sides are 1, 2 and square root 3. For sine being square root 3 over 2, we are looking at this angle, which is pi by 3. Perfect. So we have pi by 3 here. And what is this angle? This angle is pi minus pi by 3. Do you see that? So we have an angle pi by 3 and we have the other angle as pi minus pi by 3. So what you notice is that both should be added to 2n pi since the period is 2n pi. Correct? Right? Now, if I include both into one common solution, how could I write it? How could I write it? That is what you have to think about. So this is a very tricky situation, right? So once what you do is you can say 2n pi plus pi by 3 is one solution. You can say 2n pi plus pi minus pi by 3 is also a solution. Is that true? So there seems to be two set of solutions which cannot so easily be combined with plus and minus technique which we had used for cosine function, right? Now the way to combine this is to write this function as x equals to n pi. Sometimes you add the value of pi by 3 and sometimes you take away. Think about half the cycle, right? So in half the cycle, which is this pi, right? In this pi, sometimes you add and sometimes you take away. So you could write this as minus 1 to the power of n pi by 3, where n belongs to integers. Now substitute different values of n. If n is even, you are adding pi by 3. Do you understand? So it is 2 pi. So one full circle is 2 pi. Then you add, right? But if it is 3 pi, like comes here, 3 pi, 1, 2, 3 pi, then you subtract. You get an idea, right? So that is a general formula for sine function. Now that's very critical. So I'd like you to make a note of this formula. We are going to extensively use it in our solutions. Now here is third example. Let's take tan function also to complete all trigonometric functions. So tan x equals to, let's write down some value. Let's say minus 1. We haven't taken negative values so far. Now as you know, tan is negative in these two quadrants. So we could say, well, like this, right? In these two quadrants, where the angle is minus, if I see this part, then it's minus pi by 4, correct? Minus pi by 4. Now in tan, remember period is pi. And therefore, it's very easy to write the general solution. And in this case, this value of pi by 4 repeats. So we can always say n pi minus pi by 4. So both cases, whether n is even or odd, if n is odd, you are at this point, right? 1 pi, 3 pi, 5 pi minus pi by 4. This angle is pi by 4. You come to that point, right? But if it is even number, you take away pi by 4. So that becomes the general solution for tan function. Is that clear? Right? So with this in mind, we have few multiple choice questions for you. I'd like you to go through this concept clearly and then take up the test. Now here are these multiple choice questions. Question number 1. Find general solution for cos x equals to square root 3 over 2. 4 choices are given to you. You can pause the video, answer this question. We'll take up solutions later, but now it's time for you to test your knowledge. Question number 2 is based on sinusoidal function. We need to find general solution for sine x equals to square root 3 over 2. Question number 3 is tan x equals to minus 1. You need to write down the general solution. This is what we just did. Question number 4 is, now see, we have changed the angle this time. It is sine 2x. So be more careful. Use your skills to get the right answer. The last question here is very interesting. Increasing interval for the function f of x equals to sine x. I hope that will help you to understand the concepts. Once you're done, look into my solutions. Also suggest if this method of teaching helps. Thanks a lot and all the best. Now let's write down the solutions for these questions one by one. The first one here is the general solution for cos x equals to square root 3 over x. It is a positive value. We are looking for solutions in quadrant 1 and in quadrant 4. We could always use a special triangle to provide this solution, which is pi by 3, pi by 6 and pi by 2, right? So pi by 6. When we say cos is square root 3, that means the base of square root 3, hypotenuse of 2, we are looking for pi by 6 angle, right? And now we understand, since it is plus and minus, see this is plus value, this is negative value of pi by 6. So the one which matches is the very first one, 2n pi plus minus pi by 6. So that becomes the solution of the given equation. So it can be answered very fast. So in any multiple choice test, now you can easily answer these questions. I hope that makes sense. Now let's look into the second question here, which is sine x equals to square root 3 over 2. Again, I have taken positive values. That means we are looking for solutions in quadrant 1 and in quadrant 2. Special triangle being with sides 1, 2 and square root 3, and the angles, as you know, are pi by 3, pi by 6 and pi by 2. Since sine x is square root 3 over 2, opposite side to pi by 3 is what we are looking for, right? Now we have two solutions. If n pi is even, then we add pi by 3, but if it is odd, then it is subtract pi by 3, right? So that is the concept. So it is n pi minus or plus. So that minus 1 to the power of n actually gives us even and odd selection, right? So C is the right option, which gives you a general solution for sine function. So I hope this is absolutely clear. Question number 3 is with tan function. Tan functions have period of n pi, right? So that's very clear. So period is equals to just pi, not 2 pi, right? So tan repeats after every pi. So that is the period. Now in this case, we're looking for -1. That means the angle should be either minus pi by 4 or pi minus pi by 4, right? Or pi minus pi by 4, correct? Now, so that means the solution is n pi minus pi by 4, right? So what matches is option B, n pi minus pi by 4, where n belongs to integers. Perfect. Question number 4. We need to provide general solution for sine 2x this time. Now sine 2x, not x. Last time we did sine x. So again, let's do a shorter way. Square root 3 over 2. The angle here is pi by 3. So we can say 2x is equal to n pi plus minus 1 to the power of n, and the angle is pi by 3, right? So this is for 2x, right? So for x, we have to divide it by 2. That's all. So just divide by 2. So when you divide by 2, you get pi by 6 here instead of pi by 3. So the solution which matches is D. Perfect. The last one here is increasing interval. I've taken it on request of some of my students who are actually beginning to do functions, and they're having difficulty in writing such solutions, right? So let's say this is the sine function, right? Now sine function starts with 0 value, and increasing interval means from here to there, right? So this is the increasing interval. Do you understand? So it goes from minus pi by 2 to pi by 2. And then this point here is how much? So it is like 1 pi by 2, 2 pi by 2, 3 pi by 2, right? So let's write this as 3 pi by 2, 4 to 5 pi by 2, right? So that is how a general solution could be seen as, right? So let's say the increasing interval could be written from minus pi by 2 to plus pi by 2. Now next time it repeats after we add n pi in it. Is that okay? 2n pi in it. So it is 2n pi, and here plus 2n pi. Then you get the next value. To write a general term, we can factor pi by 2. So if I factor pi by 2, I get minus 1 plus 4n. And in this case, if I factor pi by 2, I get 1 plus 4n. Just rearrange this. So you could say from pi by 2, better to write 4n first, right? Minus 1 to pi by 2. 4n plus 1, correct? So that becomes the general solution for you, correct? The very first one seems to match, perfect. So, sorry, it's pi by 2, sorry, pi by 2 and that, right? So the very first one matches. So that is the true answer for this particular question. Now for some of you, I would like you to work on increasing and decreasing interval for all functions, right? So as an exercise, I will say find general solution for increasing and decreasing interval for cos x and tan x, right? So that is the question. Very interesting. Tan x may not be decreasing at all. Okay, anyway, find general solution for increasing and decreasing interval for trigonometric functions, and think about it, right? So you can also use reciprocal functions. So also work for secant x and cosecant x. It will give you good practice, and I hope it will really help you. So in short, we have learned all about writing general solutions. We began with this sheet, and here is what you really need to know. Once you know this, you can very easily answer such questions. I hope it really helps. Thanks for watching, and please do share your comments and views and also the test papers. Thanks for watching and all the best.